Muchísimas gracias. La verdad es que estoy muy contento de poder explicar aquí este trabajo. ¿Me oís todos? ¿Suficiente? Sí. Es un trabajo en el que he pensado y puesto mucho trabajo, y cada versión vais a decir si habéis mirado el papel o la versión es de hace un año. Bueno, es porque, ya sabéis, en el proceso de hacer papeles siempre, como uno está haciendo varias cosas a la vez, pues tiene que parar y dedicarse a otras cosas, pero esto me ha dado la ocasión precisamente de retomar este papel. Es algo que vamos a hacer con Isabel, retomar el papel, revisarlo y volverlo a enviar pronto. De manera que estoy también muy agradecido, no solo contento, estoy muy agradecido porque me habéis dado la oportunidad de volver a trabajar en esto. Yo creo que este es un tema bastante importante y en el que pues hay muchas cosas sobre las que todavía hay dudas, a pesar de que ha habido mucha investigación. Es con Isabel Molles, que es una estudiante de máster que colaboró un montón en este papel, pero de momento ha preferido el consulting a la academia. Yo creo que sería muy buena académica, pero está en Nueva York haciendo consulting. El papel, si no os importa, lo que voy a hacer es presentarlo en inglés porque las slides están en inglés y a veces me cuesta encontrar las palabras en español. Okay, so that's something that I have added because the other day, just going through the official statistics, these are the statistics of the Federal Reserve. These are the numbers of employment in manufacturing since almost 1940 to today. And here you can see, maybe we don't need to go to 1940. Start maybe in the more reliable things that they say the numbers from 1960 or something like that. There is a long period that goes from the 1960 to the 1980, and then you can continue on 2000, in which you can say, okay, there was an increase in the number of workers in manufacturing, maybe 3 million from here to here, and then it was a decrease of 2 million. At this time, the economists, they were saying, well, manufacturing reflects the past of the economies. Economies like the US economies are growing through services. So this reflects simply that the manufacturing has entered a stage of growth in which the growth is going to be of this type, with ups and downs and more or less stability. But then suddenly what happens is in 10 years, from 2000 to 2010, the employment in manufacturing loses 5 million people. In fact, more than 5 million people, 5.5 or almost 6 or something like that. You can see here this drop that is completely suddenly. And after these 10 years, it has been some recovery, approximately of 1 million. Here you can see the effect of COVID, that is sharp, very short, and immediately disappears. This generates a lot of questions. What happened here? In fact, probably part of the political situation that we have today is related to that. No, when Trump says that he's going to recover the employment in manufacturing to the glorious past years, he's referring that this loss in the 10 years of 5 million jobs or 6 million jobs affected life of a lot of people, no, and has had some effects in the United States that still we can see today. This is what I have said. The other thing that I'm going to put in relationship is the fall in the share of labor. Later I will be more detailed because the share of the labor cost, you can use the share of the labor cost in the variable cost. That is what I am going to do here. But many people use the share of labor cost in revenue. This is different. Here, what I have reflected is this is exactly the same numbers as before, from 1960 to 2018. That is the sample that I am using, or we are using in the empirical work. And the orange line is explaining what is the evolution of the number of workers, and the blue line, what is the evolution of the share of labor in variable cost. You see that more or less they agree, but it's clear that it's not the same. The share of labor cost in variable cost can be increasing at the same time that the employment is falling. This happens here in the 80s, and it happens also here. Is different, one magnitude and the other, or one variable and the other variable. Okay, the reasons of this evolution has been the object of enormous quantity of literature. Here you have some of the most important surveys. One survey is for Pearson and Schott. Here in 2018 in American Economic Review. This is a paper that explores the reasons. Yes? Okay. Thank you. This is a paper that explores the reasons of the evolution of the labor machinery cost. That's being Hopchin and Sapin. Grossman and Overfield, from a most macro point of view, they did also a review recently in these annual reviews of economics. And there's another review that is more micro by Pascual Restrepo, that is working with Acemoglu, and is one of the persons that has worked more intensively in automation, changing technology, and these kind of things. The problem of most of the work that has been done is that the analysis of what has happened with Cobb-Douglas technology cannot say many things, because in Cobb-Douglas technology, you know that the shares should be constant, and the share of labor should be constant. So one of the things that characterizes the Cobb-Douglas is clearly not met here. When we started with this paper, it was basically saying, okay, maybe there is a missed role for labor augmenting productivity, so productivity that is biased, that is non-neutral, like the productivity that happens in a Cobb-Douglas production function. Let's do work to see how far we can go in explaining with a multi-productivity production function that considers both kinds of productivity, how much we can explain of this evolution. With the time, we have seen that also it was necessary to use two databases that are the two main databases that the US has about manufacturing. One database is the census. Is what I list the second here. And the other is Compustat. Each one of the bases has an advantage and a disadvantage. The census, there is a version that is publicly available. So you go to the MBR site and you can download the files of the aggregation of the census. The census is even 7 years, but it has the advantage that they combine the census with a very big sample that is what they call an annual survey of manufacturing, and they are coordinated, and then you can aggregate the figures for all the years using little weights and things like that. This is a work that has been done and is in the website of the MBR and allows semi-micro analysis because you can decompose the industry in 468 particular industries. That is some level of detail. The advantage is you have representativeness because it has been treated even in the intermediate years from one census to the others in a way that you can say these numbers are the whole manufacturing, no? Or the whole, each one of the industries that compose the manufacturing. But the disadvantage is that you don't have individual data. Compustat is a database that is, was developed by Standard & Poor's. Is a database that refers to firms that are in the stock market. So there is a component of self-selection that is very important. In general, big firms and quite successful firms. At the end, so the disadvantage, the advantage is we have the individual data, and the disadvantage is that we don't have any representativity. At the end, we have seen that the data, as you will see, they don't say things that are very different. I think one of the values of the paper in the state in which it is the combination of two databases that refer to manufacturing, but that are very different in the methodology, in the way to data. No? If I had to insist in something that is important in what we find, is first, we find that labor augmenting productivity, so productivity that affects basically labor, it was very important. And not only that it's important, that also that seems to operate in waves. And one of the things that we didn't expect that we found in the paper is in 2010, both databases say that the labor augmenting productivity stops. So if you leave the methodology that I'm going to present in 2010, stops. And I don't know, I cannot say anything after 2018 because I have not worked the data. I am waiting to work the data. Probably labor augmenting productivity should be start again at some point of time, but until 2018, I can tell you for sure that there is no trace in this data. Yes.
Jordi, so I think in the literature, sorry, there is one strand that try to understand the decline in business dynamism, the secular decline in business dynamism that started in early 2000s.
Yes.
And one argument is a change in the composition where the business are being created. So, for instance, John Haltiwanger with Lucia Foster and Ryan Decker, they have a paper, I think that the title is something like Where the Skewness Has Gone, where they show that after the beginning, the early 2000s, it started like a lack of new businesses in the technology sector. And precisely the technology sector was the one that created most part of the new the employment in the economy. So they argue that because of we have fewer new firms in that sector, we have a slower aggregate job creation. But at the same time, because that is the technology sector, the productivity of that sector should be higher than the average of the economy, right? So
Yes.
maybe do you see some relationship between?
Well, as you will see, I'm not a fan of this literature.
Okay.
In a big part, I think that this literature starts with a premise that they believe firmly that there is a lot of market power going on, and the market power has been increasing during these years, and I don't find the evidence of market power being reliable. And then a big part of this literature is looking for these consequences of market power. It's not exactly the point of this paper, but I have been working on that. I will say later something more about that. But I think from say 1980 to 2010, it's clear that there is a wave of increasing productivity. And after 2010, with the methodology that we use, there are no other papers that have used this methodology. A partial exception is Raval. The Miller, I will talk about these two papers later. Stops, and it stops quite soon, as you will see. What to expect now? Well, depends if AI, for example, has a similar effect in a few years that what is the effect that we have seen here. When we relate this to the Solo paradox, the Solo paradox is a reflection of Solo that joking says, well, computers are everywhere, but in the statistics, we don't see the effect of the computers. This has been called the Solo paradox, no? Because there is no evidence. The first thing that I have said is something that we prove with the data. What I am going to say now is more an speculation. We think that one way to explain what we see is a way that says the Solo paradox partly is solved because what we are seeing from 1980 to 2010 is the wave resulting from the computerization of the industry. And there is a moment in which the increases of productivity that you get from this computerization are marginal, they stop. Probably we will see from this point of view in a few years maybe a new wave that is related to the artificial intelligence thing, but still has not started or had not started in 2018. Yes.
So this is data for the US.
Yes.
Right? Do you have an idea whether this was happening in other countries?
The stop
as well?
No. This is the first time that I have found this in the data. It was a surprise for me. It was really a surprise. The other thing that we can insist, we can discuss deeper these things later. Many people discuss about if we need to put some policy measures to limit the expansion of labor augmenting technologies because can affect negatively the employment. You will see that paradoxically, what I'm going to say is that just these technologies through what can be called the compensation effects is a big part of the increase of employment. So the increase of employment that was, in any case, was in fact related to the introduction of these technologies. So this means that, in fact, it's very doubtful what we should do about these technologies. Well, the plan is discuss first the model. The model has many pieces. I'm going to give you a intuition about the model. I will discuss the production function, how is the demand for labor, what the model predicts for the labor share. And then I will discuss something that is key, that is what is the output effect of technology. That is, in fact, the part of the paper in which we need to have more ideas about how to do the things, because it's the part that we have less data for doing estimations that are completely reliable. Details, if I have time and you like, I will explain a little more technically the production function, what happens with the labor share, and how we treat the demand effects. And in the empirical part, I want to show you the evidence that we can call reduced form evidence without models. Basically, I am now convinced that one of the first things that any researchers that is interested in employment or technology should do is look at the shares in cost. I'm going to give you some insights of what we do and what can be done with to obtain relevant evidence. And then I will show you the estimates of the production function with the two databases. And the result of the paper is take the estimates of the production function, put some more assumptions, and then decompose. Try to give reasons for the weight of each one of the factors in the evolution of the plan. And then I will move to the conclusion. Production function. We take this can be applied with any type of production function, but the production function that has meaning to apply is a production function that can admit an elasticity of substitution that is different from one. An elasticity of substitution of one is what characterizes a Cobb-Douglas production function, and then the shares of the inputs are going to be constant. It cannot happen what we see here. We can do this work with any production function that makes explicit Hicksian productivity that affects the whole production function, so each one of the factors, and another productivity that is affecting only labor. Omega here is what I have applied with my co-authors in previous works, and I think it's quite standard in the literature. Omega reflects approximation in percentage of the efficiency of this particular firm or this particular industry. If you apply to an industry over a firm or an industry in which this term is zero. No? So you expect at the end to characterize the distribution of omega H's, and these omega H's are saying you this firm has 20% more than the firm that has zero, or this firm has a productivity that is minus 20% or minus 15% less than the standard firm. When I use Q star is for the part of the production that would be relevant, but unfortunately we don't observe this. Epsilon, that is very classical in production analysis, is very annoying because it's an epsilon that impedes us to know what is the really relevant output. No, the output that we observe includes this epsilon. We are going to assume, for simplicity, that the production function is separable in capital. So this is notation for the case in which it's separable in capital. This simplifies a lot the algebra, but it's something that can be relaxed. I'm not convinced that the relaxing that is going to be changing anything that is important, but there are people that want to do that. And we are interested in one case that we think that, or I will explain you later, is the relevant case, that is in which the elasticity of substitution is less than 1. If you take a production function of this type and you derive the demand for labor, demand for labor is going to give you 4 terms. This first term, you can say, is the direct impact of productivity. What we expect is that if you are in labor augmenting productivity 30% more efficient than the firm in which this is 0, you are going to have an impact in the number of workers, so 30% less number of workers or number of hours. No, it depends on how you measure. You have the direct effect of the 2 types of productivity. This is the effect of the prices, and the important thing in the labor augmenting productivity is that the labor augmenting productivity has what we can call a price effect. If you think of an efficient worker, later I will use for the efficient worker instead of L, I will use L star. An efficient worker is worker augmented in the productivity, labor productivity. An efficient worker, when the labor productivity increases, the price or the cost of the labor worker decreases. And that's an important part of the analysis. And this is what gives here something that is special. C1 is the derivative of C, that is the subfunction that you use when you take when you deduce the labor demand conditional and output. This C1, it depends in logs of the difference between the wage, the price of material, but also the productivity of labor. This is to control for capital. If we were more complex, assuming non-separability, it would not be an additive term. The advantage of this additive term is, if you want, you can read everything that we are saying about the evolution of labor as conditional capital. No? You can say what we are seeing is approximately what happens in number of workers per unit of capital. And this simplifies a lot the things. And as I am using the labor demand conditional in output, we have here this output that is unseparable. This means that we can distinguish 3 effects. This is quite similar to what Acemoglu and Restrepo also discussed. There is a direct effect that sometimes is called the displacement effect of the technology. There is a substitution effect that operates through the prices, and there is something that remains that we will have to put a lot of work for saying how this is affecting employment. Is the effect through output, because the change in technology is implying a change in the Q, that is the Q relevant for the firm, and then this is the effect through output that you will see in a moment. This key effect. When sigma is less than 1, the sum of these two effects is going to be negative for the environment. And the reason is the derivative with respect to the direct effect. This can be read as a semi-elasticity is -1. And here this effect is like the effect of the wage on the labor, and the effect of the wage on the labor with a little algebra, you can see that is 1 minus SL, where SL is the labor cost on variable cost, and this is sigma. If sigma is less than 1, this product is less than 1, and the absolute value of this is less than 1. And this means that the result of these two first terms is always going to be, according to theory, negative in employment. That's an additional reason why the effect of output is important, because the effect through output should compensate this. If not, the effect of technology, when there is labor augmenting productivity, is going to be negative. This is different from what happens with a neutral productivity. With neutral productivity, we don't have substitution effect, we have only displacement effect. And the output effect in general is very simple, because what happens is that the omega Higksian also enters in cost, and if the elasticity of demand is 1 or more than 1, then technology can never have a negative effect in employment. Here we will see that it's a little more complex when we discuss the output effect. This first part is negative, and it can be the case theoretically in which Q doesn't compensate enough. So in principle, this is a logical thing to be worried about labor augmenting productivity, because it's not clear what is going to happen with employment. Labor shares, the analysis.
Sorry, one thing. And for this labor demand, are you assuming that it's price taking in the perfect competition in the input market?
No. All this is completely.
The B parameter, this is related to, it's like a scale parameter, or?
Sorry. Yes, they are completely. Sorry. Thank you for this. The Greek letter, I think we should not say is mu. This nu is what we call the elasticity of a scale. So it's the sum of the elasticities of the variable factors. All the time, I am going to be assuming that the variable factors are L and M, and then it's the sum of the elasticities of L and M. Here I put nu. Nu can be fact variable, the same as the elasticities. In practice, we are going to do the example that we do with a nu that is constant. But this is a simplification that can be generalized also. Thank you very much. Labor shares, well, it was Higgs the first that discussed that. No? You have here the weight of labor in the variable cost. Manipulating this a little, it's very easy to see that this is simply a function of the relative prices and the relative quantities. So if you divide by WL, is PM divided by W and M divided by L. So these are the two determinants of. And is when sigma is less than 1, Higgs said this is going to decrease with labor augmenting productivity. And then this means that the labor shares in variable costs are going to diminish. And if we are not in a very special situation, the labor shares in the total cost also, they are going to diminish. Usually the share of capital is quite constant. And there is a result of theory that says that completely in general, the elasticity of a variable factor is no times the share in cost. So this is going to imply also that the elasticities are going to fall. The elasticity of labor is going to fall. In fact, Higgs, what says is, well, labor, to explain intuitively, says labor becomes more abundant because the productivity of every worker increases, and then the factor is the more abundant factor. If sigma is less than 1, is going to diminish the weight in the cost. And that's a technical thing. If you think of the isobar, sigma is a condition on the slope of the isobar. So this simply means that when there is any variation of the prices, and it's going to be a variation because of omega L, then what happens is that the variation in quantities with sigma less than 1 doesn't compensate exactly the variation in the prices. And then this is what is going to determine that, for example, if workers become cheaper, in principle, you are going to increase the number of workers, but not as much as the wage is falling. And then this is the reason by which the share of the labor cost in the cost is going to decrease. Okay, later I will put the accent in something that is general in many countries, has been shown at the firm level. When you see the shares of labor cost in cost are decreasing. It's what I will insist as a reduced form evidence. Output effect. The output effect, we are using a conditional demand of labor. So the output is determined in another way. This is the demand for labor that I have specified only in a generic form, written in a generic form. And here we have the other equation that should complement that. Where the firm determines the output? The firm determines the output in the output for the market, and this output is going to depend on the price that the firm sets, the price of the rivals. This is a vector. If you have many rivals, many prices that you should take into account, and A stands for an intercept. So everything that is not your price and the reaction of the competitors is in A. So this particular product that you are producing, this industry is losing weight because consumers think that this belongs to the past and they don't want to buy so much as before, then this is in A. If China is competing in this market very heavily with products that are similar, this is in A, and so on. Yes?
You're not assuming constant return to scale yet, right? You're not assuming constant return to scale?
No, because we have this nu. This nu can be, this nu is arbitrary nu, and in addition we have the elasticity of capital. That the long run elasticity will be nu plus the elasticity of capital. We have not put any restriction on it. Okay. In imperfect competition, we think of the firm setting the price as marginal cost plus the log. This is an identity, plus the log of the ratio P over MC. So mu is P over MC. So this is in fact a sort of identity. But we can use this identity to decompose the variation in price, especially when we don't have price, in variation of, even for simulating the variations in price using variation in marginal cost and variation in mu. The variation of mu, we are going to do the only thing that I think is reasonable in a quick work, that is take the variation in mu that you see in the data. We can discuss later if you want how you measure that. There are many reliable ways to see what are the relationships, what are the variations of the markups for the firms. The variation of MC is just what we can approximate as an effect of technology, just because we have estimated the production function, because the production function allows you to write the cost function, and then in the cost function you can keep K and the prices fixed, and then you can move only the technology, you can move only the two omegas, the omega that reflects the labor augmenting productivity and the generic productivity, and then you have a variation of MC that is a variation, the variation that according to the productivity of this firm is the productivity that is going to affect marginal cost. Then doing a linear approximation, you can say, what is the effects of technology that we will see through this unobservable cube? The effects of technology, it will be the effect of technology on marginal cost. We expect productivity with staying constant, reduce marginal cost. And if the elasticity is theta, then this is going to be impacting positively the Q. But if the firm reacts raising the price, and there is evidence that the firms just use this type of situation in which there are increases of productivity to raise the price, because then they last markup during some time in dynamic models, that's very common, then this is going to reduce or diminish the effect of technology through Q. So here basically is saying in the decomposition that we did before, in the decomposition that we did before, this term has a lot of things, but if technology diminishes marginal cost and the firms pass these to prices, this is going to have a big positive impact in employment. But if the firm behaves using the reductions in marginal cost, just more prices, is going to diminish the effect on labor. And well, it's an empirical thing to say what are these effects. Okay, details. I'm going, except that you say to me that you are very interested, we can be quick in that. So with my clausule, we first use translog separable in K. It's not needed to separate this. An article coming out in RAND that says that you can serialize this, and it's true on ECC. But do separable and even suppress this term in capital square changes very little and simplifies the things. And then this translog has the advantage that can be specified in terms of efficient workers, so workers with productivity that is labor augmenting. You can the Higgs neutral productivity. And if you impose homogeneity, it becomes a beautiful production function, very easy to estimate, in which what you have here is a term in M and two terms, one linear and another quadratic, that depends on the ratio materials efficient there. And Well, this is what we use. We use first with my co-author in a paper that is called using cost minimization to estimate markups. And since then, I have used many times. The elasticities of labor and materials are varying. And you see that they are varying in the way that we expect that they are varying. For example, here, if labor becomes more abundant, this is with minus, so the elasticity of labor is decreasing. And if labor becomes less abundant, it happens the opposite. And the advantage of this specification is the sum of the two elasticities is a constant. A constant that we don't impose a value, but it's a constant. And this makes very easy the exercise. When you work the ratio of these two order conditions, the first order conditions that I have been handled, because this is the special. You take the first order conditions, you take the ratios. In the ratios of the first order conditions, the Higgsian productivity disappears because they both multiplying both first order conditions. That's completely general. You don't need a specific production function for that. And then you can isolate an expression that is an expression in the labor augmenting productivity. The problem is, and this is quite subtle, is that this expression is arbitrary up to a constant. You can understand this intuitively. This is why I have here C. Intuitively, you can say here we have one parameter that we want to identify, that is AL, that is not going to be the production function, and we have here C. Both things at the same time cannot be estimated, obviously. You can think of, we have redefined workers, and if we redefine workers, we need to say what is the origin of this redefinition, what is the omega zero. No? We should put at some point of time, because when we are going to say this worker is efficient, because if not, we have a problem of identification in the production branch. Then just doing the normalization can be understood as fixing a mean for the labor augmented productivity. But that's a completely technical thing. More important is that with this kind of expression, we can plug in the production function, and then the production function becomes an expression in terms of materials and the share of labor, not labor directly. And this is the form that we can use to estimate the production function, and can be applied with distance log, or can be applied with more complex ways. And we still have here the Higgsian neutral productivity. We can apply what is called the dynamic panel transformation, that is basically differentiating the equation. And in principle, here we have an expression in which there is no unobservable. We have not imposed a value for sigma. With a translog, the sigma is varying. So what we should do is use this expression to check that effectively we are getting a sigma that is less than 1. Yeah, effectively, very well. This is Higgs reasoning. I don't think that I need to go with detail over that, because it's very technical. Basically, it says that with an implicit function thing that you get from the ratio of the first order conditions, you can reach the conclusion that in completely general terms, you are going to have that the impact of the increasing of the labor augmented productivity is going to make the share of labor cost in in cost falling when sigma is less than 1. No? And it's going to happen the opposite if sigma more than 1. That's easy thing. Industry effects. Here we have a big problem, no? Because usually we are not going to have any information about the price of the rivals in the industry. What do we do? Well, take this expression, log differentiate. What we have here is something that is quite standard. We say, okay, output is elasticity with respect to the own price plus the elasticities with respect to the price of the rivals plus this intercept. When you aggregate this for all the firms, this second term, this is the effect of J in all the rivals R, but each one of the rivals R has an effect in the demand of J. So when you aggregate, what happens is that you see clearly that the analysis of employment cannot be an analysis at the firm level, because when you aggregate in the industry, what is happening is that you have effects in the demand that are net effects, that basically they are saying when you decrease your price and then you increase your output, you are stealing outputs from the other firms. And then if you want to be complete in your analysis of employment, what happens is when you decrease your price and increase your output, you increase your employment, but you are stealing or you are destroying employment in the other firms, and this depends on how is competition. So this would be in a linear specification, what would be the net effects. What we are going to do with that? Because there is no easy way to compute these net effects. We are going to do two things. First, we are going to start by assuming that the elasticity of demand is 4. Why 4? We will see that even if we do something that is more than that or less than that, conclusions, they don't change. And with our aggregate data, we try to do an estimation. And the estimation says, well, this net expression, the data say that it's realistic to suppose this 3.5. Okay, this is what we are going to do. Okay, let's go to the empirical part. Reduced form evidence, the fair regression. I have done this regression with Chinese data. It's beautiful. I have done with Spanish data. It's perfect. I have done with this US data and gives something very clear. You have a big database. You have many shares of labor in cost. If you have the wage bill, is simply dividing the wage bill, but the variable, the cost that you suppose that are variable. Then you take the log of that and you subtract the first observation that you have, because you are going to try to measure how this sharing cost is varying. Tau is the number of years that are passing. So this regression simply what is saying is what is happening over time with the labor sharing cost. Which time? Because unfortunately, in general, the only thing that we can do is the time that the firm has been in the sample. Of course, it would be better if we could distinguish this is the first year in the sample and it's also the year in which the firm has been created, but many times this is not possible. In the United States, it's not possible, so what I'm going to show includes firms that is the first year in the sample and firms that they were already in the industry, and it's the first year that they are in the sample, but it's not firms that they have entered. You can call these survival dummies, and supposing that the error is uncorrected, this is what the regulation says. Yes.
So you're using CompuStat data for
Yeah.
Okay. So
this says exactly when you see a firm after 2, 3, 4, 5 years, the expected value of the share of labor with respect to the value that you observe in the first year has diminished in this. And basically this is saying in the 6, 8 year, the share of labor cost in cost is between 5 and 6 points less. So it says over time, the shares are decreasing.
and this is evidence or suggestive evidence.
This is evidence that if it's not evidence about the wages decrease over time, or there is no evidence of other macroeconomic exchange factors, this is evidence about labor augmenting productivity, about the Higgs effect. No?
So because what I was thinking that in the aggregate, still, so here you are capturing like the effect coming from the improvement for existing firms in the technology that they are using, right?
Yeah, this is the firms that you observe. You take all the information because you want to be very non-parametric. These are means, simply, no? The only thing that you do here is means. You can call this is a non-parametric regression because there is nothing that you impose from theory. You are saying, when I follow the firms over time, the share in costs of labor is falling. And this happens in China, happens in Spain, happens in US, and happens probably in more places. In China, my author says that in the recent times, it makes sense, instead of decreasing, are increasing. But the political change in China has also reversed the position of the workers in the firms. So there is like a reinstatement of all rights of the worker that during the part of transition to the market economy disabled. I don't know, because I have no.
But what I had in mind is that still you could have like an additional effect that you are not capturing here in the sense of like the Schumpeterian creative abstraction, because here you are.
No, it means for the firm.
Exactly.
Yeah.
So you
yeah, but this is what I wanted. So in fact, this regression that I try to sell as a regression that is doable and interesting to do is to separate from aggregate things. No, you simply say the mean of what I observe is a fall in the share of it.
Yeah, but still you could have like new firms being more productive.
Yes.
Than older firms,
yeah.
Right? But and that would increase like the aggregate effect because it would be an additional effect on top of what you are
with the Spanish data that we can distinguish the firms that are entrant firms. We have at the beginning a couple of years in which it's not decreasing, is even increasing, and this effect disappears when you take out the entrant firms. What this would be saying, if you are an entrant firm, your technology, the 2 first years goes in a opposite direction than the other firms. But after 2 years, you start this process of decreasing of the cost. Okay, that's okay. I will say in a moment a little more about that. Estimating the production function, we do. I don't have here the results of the production function. I have only the graphs. Well, In both samples, it gives the same nu, 0.9, that is theoretically quite okay. The dynamic panel specification to get rid of the Higgsian productivity gives the rho, the autoregressive parameter gives approximately 1. So the estimates that we have are perfectly compatible in both cases with the presence of fixed effects. Our estimation of Higgs neutral productivity and labor augmented productivity are approximately this is Higgs neutral productivity is growing 0.5% every year. We are considering a very long period. And labor augmented productivity, we get a different thing in the aggregate data. We get an increase of 1%. And in the firm level data, in which we get a number that almost doubles. You see that the omega L is affecting labor. In fact, what we are reproducing here is what we call the output effect of the labor augmenting productivity, because the omega L you should translate when you increase the efficiency of workers in this omega L, what is the effect in output? And what is reflected here is the effect in output, just to make comparable to magnitude. Then, what suggests the data? This is the firm level estimation in orange, and the industry level estimation in blue. You can see that they are quite, these are averages about 5,000 firms and 500 industries, and the data are different, is quite coinciding. But if you look at a little more detail, you see that in fact, it seems that the 80s, the growth of the labor augmenting productivity is bigger for the firms than for the industry. And just after that, around the 2000 or 2010, it seems to change. And what seems clear from this graph is in both databases, from 2010 until the end of the sample, it seems that the growth disappears in both databases. This is where we started to think about the question of the wave. And you can here confirm the wave. If you put all the omega L's estimated and you draw the density in the 80s at the beginning of the 80s, for the firm levels, this is the image. And what happens when you arrive 2010 is reflected by the blue line. The firms that they were in this area, they have become more efficient. The productivity has grown, but also this distribution is more concentrated, so the firms are more equal than as they were at the beginning. And in addition, from 2010 to 2018, there is no change in the distribution. This is what we call the wave. No? And this can be complemented by the other thing, that is the analysis of what happens in the industries. In the industries, when you look at the growth from 2001 to 2010, what happens is the industries in which the level of productivity was less, they now are growing faster than the industries in which the growth of productivity was already high, in which the growth 2001 to 2010 is less. So if you put all these things together, it's saying, well, that's like something that originated in the 80s in the big efficient firms and started to extend to all the firms and to all the industries. This is what I call the wave. It's a completely classical process of diffusion or something. Maybe, and this is speculation, the diffusion of the computerization of many tasks in production and in the management of the firms. Let's do the composition. Using the demand that I have shown before, with a slight change of ordering and things like that, taking differences, you can say, okay, what I see of change in employment can be attributed at a direct effect of what we are estimating firm to firm. The effect of the prices separated of the substitution effect, that is an effect through prices, but an effect of labor augmenting productivity. This is an important aspect. The first is negative. We expect this substitution effect making milder the displacement effect. This is the impact of capital, and this is the output effect. The output effect is what we want to go deeper, and one possibility is what I have explained before, do really a computation, a structural computation of what we expect impact of productivity marginal cost. This formula is taking into account that nu can be different from one. Nu is one. This is simply the elasticity. And here we are going to adopt what we see in the data as reactions of the markups. You can say, oh, but these reactions of the markups, maybe they are to other things. Yes, but what a limitation, typical limitation of the empirical work. Let's do two tables. First, I'm going to discuss technology and prices without output effect. What do we see? Here you have divided in relevant subperiods. First subperiod up to the 80s, from the 80s to the 2000s, 2010, and then the last one, the period in which I have announced to you that there is no labor augmenting productivity. This is firm level, and the bottom panel is industry level. You see that the industry level says no growth of employment, decrease in 1% per year, decrease during the 10 fatal years, 5% every year, no variation of employment data. You see here clearly the character on the one hand self-selected and better performing of the firms, because the firms starting growing employment at 5%, continuing at 3% in the years 2000, 2010. Some fall employment, just increases only very small 1%. And in the last period, employment is increasing again in the composite sample. No? This makes sense. We know why this happens in the two samples. Here we have added lots of small firms, and in the first sample, these small firms are working anything. No? Yeah.
Also, you could have something of related to the business,
Related to?
to the cycle of life of the businesses. Like at the firm level, you can capture the firms from, I don't know, a very early stage, so they have to grow.
Yeah, the number of years that the firm, yes, but I think in principle we suppose that here we have all the population, and here we have selected population. We are not especially interested in principle in what we do now, in what type of selection. I have in any case in the paper an analysis of this evolution of this sample. here you have the mean of the omega L's and the omega H. You see that the omega L is really important. It's really important at the level of the firms, at the level of the industries. And as I have said to you before, completely stops. In fact, the sample firm says that reverses a little. But I'm not going to make this an important point, but I don't think this. The omega H in general is around 1% a year, except in the sample of firms in the two latest periods, it seems that the Higgsian growth of productivity is a little increasing, no? Up to 2 points or even 3. The price effect, this is the price substitution effect, are always with the sign that we expect and are very significant and are reducing these enormous direct effects of the labor augmenting productivity. But when you take these numbers and you do accounting, you see that it happens what we were expecting from theory. If the 3 columns, they were the only relevant columns, labor is falling always as the result of these 3 effects. So what is key is the output effect. And the output effect, and what we do is here additional decomposition. No? Here you have the output effects of the first table, same separation from level, industry level, same periods. And then we try to see if the markup, the variations that we observe have been important. In general, the variations of the markup are 2 up and then are having an effect on employment that is negative, but it's very small. It's really small. You see the fall of the marginal cost with the methodology that I have explained to you is quite important and explains if you look at the firm level effects, this is 65% of the variation of employment. And the intercept is the residual. So this is not an independent thing. This is what remains to be explained. And what remains to be explained that you can attribute to exogenous demand, well, you see that in general, in the firm level has been positive except in the 10 years, and in the industry sample has been almost around 0 and very sharply determining the falling of employment in the decade. So what emerged from here? Well, this is saying productivity, in fact, is not having a negative effect. When you take into account the output effect, productivity through the compensation effect is increasing employment. What is decreasing employment? What is decreasing employment is the fact that here, for example, in these years, really the demand falls a lot and falls even at the level of the firms. So probably there is something of the China shock that is quite real in the sense that the firms experience that they were invaded in the industries by Chinese products that they couldn't sell at the same level. Of course, if you interpret it this way, you need to say also that it seems that they reacted, no? Because in the next 10 years, they have reacted. In addition, that the effects are important and the reduction in marginal costs are important, we see that it's clear that it's not permanent. In 2010 seems to stop. We don't know exactly why. And I have been very quick. I have not explained you the calculations with the other elasticity. These calculations that I have shown you are done with the pessimistic elasticity, so are taking into account the cross effects. So these positive effects of technology are effects taking into account that when you create employment in your firm, you are stealing employment from other firms. No, so we are. You can be, if you want, even more moderate about the elasticity of demand. You remember that we are using an elasticity of demand that is 0.4. You could be using 1.5, and still most of the conclusions would hold. So it's not a problem exactly of the elasticity of demand. Then one inevitable conclusion, it seems that really there was something in demand that was abnormal during all these years. Okay, I think I have talked too much. Thank you very much for all this attention.
Any questions? Thanks. Yes.